Hi, I'm Donald Sinclair. I'm a science teacher with Great London Tutors, and today we're going to be looking at a few topics in chemistry. This is a guide to endothermic reactions. Chemical reactions can be either exothermic or endothermic. This describes how heat is either taken in or given out during the reaction. Exothermic reactions are probably the ones you're most familiar with. Any reaction that gives out heat is called exothermic. For example, most things combusting or burning is an exothermic reaction. Endothermic reactions, on the other hand, take heat from their surroundings, so they have a cooling effect. Chemical ice packs, for example, use endothermic reactions to give a cold sensation. The reason that exothermic reactions heat up and endothermic reactions cool down their surroundings is to do with how bonds are either being broken or formed in the chemical reaction. In an exothermic reaction, a chemical bond is being created. Since two atoms bound together have less energy than two separate atoms, that excess energy is being given out. You can think of two magnets suddenly being pulled against each other and giving out some energy. In that case, it would be in the form of sound. You can imagine it here as heat energy being given out. In endothermic reactions, the opposite is happening. A bond is being broken and two atoms are being separated. Now, to break a bond obviously requires energy. So energy is being taken in from the surroundings, which is why it has a cooling effect. Again, you can think of two magnets stuck together that require energy to be separated and to be put on their own. Let's look at an example which involves both bond breaking and bond forming. To find out whether our chemical reaction is exothermic or endothermic, you need to calculate how much energy is needed to break the bonds and how much energy is given out when the new bonds are formed. Let's look at the reaction between methane and fluorine to form fluoromethane and hydrogen fluoride. Now, every bond has an energy associated with it. This is the energy that's required to put into the atoms, into the molecules, to break the bonds, or it's the energy being given out when those bonds are formed. For example, the carbon-hydrogen bond has an energy of 413 kilojoules per mole. That means that one bond being broken per methane molecule in 1 mole of methane would take 413,000 joules. So if we look at the structural formula, we can see that one hydrogen is being removed from the methane and being replaced with a fluorine, which comes from the fluorine gas. So what bonds are being broken on the left-hand side? Well, we have one carbon-hydrogen bond being broken. This requires us to put in 413 kilojoules per mole. The plus sign is there is because we're putting energy into the chemicals. Energy is being put into it. We also have to break the fluorine-fluorine bond because the hydrogen is going to come in later on. So we also add 158. This means that the total energy required to break the bonds in the first place is 413 plus 158, which is 571 kilojoules per mole. What bonds are being formed? Well, we have one carbon-fluorine bond, which has an energy of 495. Now, because the bond is being formed, that means energy is being given out, energy is being lost by the chemicals. So we put a minus sign. Also, the bond being formed is the hydrogen-fluorine bond, which has an energy of 565. This is the total of the energy being lost by the chemicals. This energy will be given out and will be absorbed by the surroundings. Therefore, this is an endothermic reaction because energy is being taken in, the surroundings cool down. And this is an exothermic reaction because energy is being given out, the surroundings heat up. We can see that the total energy being lost by the chemicals is 1060 kilojoules per mole. Now, because the amount of energy being lost by the chemicals is greater than the amount of energy being gained by the energy put in to break the bonds, overall this is an exothermic reaction, which means when this reaction takes place, the surroundings would heat up. If it happened to be that the energy being taken in was bigger than the energy given out, it would be an endothermic reaction.